Congratulations, if you've made it this far, this is the last station of all of the things. So this one's on applications, so you'll need your graphing calculator. So we're going to just do this one that says, suppose the height of a water rocket in feet can be modeled by the function h of t equals negative 16t squared plus 79t plus 4, where t is the time in seconds since the rocket has been launched. So personally, what I do first is I kind of just make a sketch of a graph, and I'm going to label my axes. So you can tell from this function over here, since sorry guys, my screen is sliding everywhere. Since the t's are over here, the t's are on the x-axis. And it says that the x's are time in seconds. It says that right here. T is time in seconds. And then y is the height. So I'm going to put height here on my y-axis, and that is in feet. Okay? Then you're going to press the y equals screen on your calculator, and you're going to just enter that equation. For the interest of time, I went ahead and already entered it. So there, you'll enter it. So pause this if you need to, and then enter it. And then we're going to press zoom 6 to start and see what we get. So you can kind of see on my graph, I got these two blue lines, and that's because my graph doesn't go high enough. So I'm going to press window, and I'm going to go higher on my y. I don't really know how much higher at this point because I don't know what's happening. So I'm going to change it to 100, and then you just press graph. All right, that's better, as you can see, but I still can't quite see the top. So I'm going to go back to window, and I'm probably going to go change that 100 to, say, 150. You probably don't need to go that high, but that's what I'm going to do. There we go. So right here where it says window, it says x min, which is the lowest x. So for us, the lowest x we put was negative 10, and the highest x was positive 10. And the lowest y was negative 10, and the highest y was 150. And I'm just getting that from the window screen on my calculator, okay? If you recall back in Unit 1, we found the maximum pretty often. So this question says, what is the maximum height of the rocket? So since it says height, I'm looking for a y value. So I'm going to choose second calc maximum. And then remember, my calculator is going to ask me left bound, right bound, guess. So right now I'm to the left of my maximum. So I hit enter, and then I go a little bit to the right of my maximum and hit enter again, and then towards my maximum and hit enter one last time. And there it is. But since it asked for maximum height, I only want the y value. So that y value is 101.516 feet. Okay? Every single time you read these, you have to figure out if you're given x or y. So letter B says, how high is the rocket after 2 seconds? So if I go up to the graph that I drew earlier, seconds is on the x-axis. So this is basically just like fancy math for x equals 2. So I press second calc, and I choose 1 for value. And at the bottom, it's just going to let me enter x equals 2. So I'm going to enter a 2 and hit enter. So it gave me x, and it's asking me for y, which turns out to be 98. So this is 98 feet. Next question said, at what time or times will the rocket be 75 feet in the air? So since it says 75 feet high, that's a y value. So this is equivalent to saying y equals 75. In order to enter that, you have to go to the y equals screen, which shouldn't be a shock since it says y equals 75. And in the second y equation, we're going to enter 75 and then press graph. And what we should be seeing now is the quadratic with a line at y equals 75 kind of just going across. And what we need is the 2 intersection points. I can't draw on my calculator there, but I can draw over here. So what we're looking for is the coordinates of this point and this point. And we do that by choosing second calc 5 for intersect. So right now my calculator says first curve, and you'll notice that my cursor is on the blue graph. So I press enter, and then it pops up to the second curve, which is the red graph. So I press enter. And there are 2 intersection points here, so I'm going to move towards the first one. So when it says guess, I'm going to press that one. And so it's asking for time, which is the x. So that's 1.181 seconds. In order to get that second intersection point, I have to just do it again. And it's going to do the same thing. So right now it says first curve and it's on the blue graph. And after you press enter, it'll run to the red graph. Press enter again. And now when it says guess, you just have to go towards the other intersection point. So I already found the one on the left. So now when it says guess, I just go towards the one on the right and press enter, and I'll get the other answer, which appears to be 3.756 seconds. One more question. How long will it take for the rocket to hit the ground? Okay, so when it hits the ground, its height is 0, and that's this point on the graph. You see what I'm sketching on this thing, and that is the x-intercept. And another word for x-intercept is a 0. So on my calculator, I'm going to do second calc and choose 2 for 0. And what I'm looking for is over here where it's hit the ground. So it says left. So I'm left of my x-intercept, I hit enter. And then I go a little to the right of my x-intercept and hit enter. And then kind of near my x-intercept and hit enter. And so the x value we get here is 4.988 seconds. So the only parts of that should be new from last unit is, let me think, is B and C. A and D we had done in unit 1. So why don't you give the next 2 application ones a try?